This problem is from chapter 23, number 10. It says, in periods of peak demand, power companies lower their voltage. This saves them power and saves you money. To see the effect, consider a 1200 watt coffee maker that draws 10 amps when connected to 120 volts. Suppose the voltage is lowered by 10% to 108 volts. By how much does the current decrease? By how much does the power decrease? Caution, the 1200 watt label is valid only when 120 volt is applied. When the voltage is lowered, it is the resistance of the toaster, not its power, that remains constant. I will mention something later to that effect. In any case, so what we have going here for the coffee maker is that the 1200, that's rated at 1200 watts, only if the voltage is 120 volts. But now that voltage is lowered by 10% to 108 volts. So 10% decrease here. That's what they say. Okay, by how much does the current decrease? Well, for that I have to do this calculation. First of all, figure out what the current is, the original current. P equals I times voltage, which means that the original current is power divided by volts, which is 1200 watts divided by 120 volts. And I'm going to write down here the original current. There we go. Which is 10 amps. That makes sense because 10 amps times 120 volts are 10 amps times 120 volts are 1200 watts. Okay, now what I could do is just take the 10 amps and multiply by 108 volts and come up with something. However, I'm just telling you that's not correct. Let's do something else instead, and that is determine what the resistance is of the coffee maker. And that's what it says here. It's the resistance of the toaster. Ooh, interesting. They say coffee maker first and then they switch that to toaster. Oh well. It's the resistance of the toaster. It stays constant. So let's calculate the resistance. R equals 120 volts divided by 10 amps. So, oops, you know what? Start over again. Because I meant to write down here proper form of resistance, volts divided by current. So I have 120 volts divided by 10 amps, which means that our coffee maker or toaster or whatever it is has a resistance of 10 ohms. I repeated that because I had forgotten this one here, and then I wrote down the wrong unit there accidentally. Okay, in any case, now it says that the resistance of the toaster coffee maker is the same at 10 ohms even at the new voltage. So let's calculate for the new voltage, and something interesting will happen here as we calculate the electric current for this one here. Electric current with Ohm's law is going to be voltage divided by resistance. So the new voltage is at 108 volts. The resistance is still 10 ohms. That's what they say in the problem is the same. Any appliance or electrical part where you don't change its makeup will keep the same resistance, 10 ohms in this case, and I come up with 10.8 amps. And notice that that is different, and it doesn't look right the way I calculated this. Oh, geesh! I hope you noticed that mistake earlier. Oops. That might be the very first time ever that I can correct one mistake, because maybe I didn't make a mistake earlier. Anyway, 120 divided by 10, that's not 10 ohms. Sorry about that. That of course is 12 ohms. There we go. Which means that down here I have 12 ohms. I distracted myself because my computer is doing something else. And so my eye keeps looking to the upper left corner outside of the screen here, and I distracted myself. Anyway, and then 108 volts divided by 12 ohms indeed is, if I find my calculator here, a little over 8 amps. 9 amps. 9 amps, which is definitely not the same as this one here, which is also 10% lower, and that's what they're saying, 10%. By how much did the current decrease? Well, it also decreased by those 10% down to 9 amps. And that makes sense because for the same resistance of 12 ohms, going to a lower voltage means that we have to get to a lower current as well. Okay, let's see what the power is. So the new power is current times voltage, which is the just calculated 9 amps times 108 volts, and that one comes out to 972 amp volts, which of course is watts. So the total power has decreased appreciably from 1200 to 972 watts, approximately by 20%. Not exactly, but that's because as you subtract 10% twice, and this is what happens here, you subtract 10% here, you subtract 10% here. So as you subtract 10% twice, what you actually do is you multiply by 0.9 instead, twice, and therefore you come up with 972 watts as the power for the coffee maker or the toaster, which means if you get less voltage from an outlet, your appliance isn't going to work as well as it should, which may be okay, just leave the toaster on for a longer time. But if you went the opposite direction, that could actually cause a hazard or be a hazard, because now you would actually draw more power than the appliance allows, and then it may fry itself. So as you go to the higher voltage, pay a little bit of attention, especially if you go to another country where they may have a voltage from the outlet of 240 volts and where then should use a transformer.